AI data centers are a hot topic for a lot of space companies. That includes SpaceX, who have applied for putting 1 million satellites into orbit. So, is this a genius idea that will put more money into space exploration and boost orbital infrastructure? Or are we all cooked when the bubble will burst? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, gather them up, and I will answer them here. We had a big piece of space news in the last couple of weeks, which is that SpaceX is planning to put AI data centers in space. And so I had a bunch of questions about that. So we've bundled that together into this show. All right, let's get into the questions. Mr. Spaceman, how screwed up is our economy that placing data centers in space is the best option? I mean, I think we all have experienced how screwed up our economy is. Regular people are seeing inflation rise. They're seeing various costs go out of reach. Things like being able to buy a house, the cost of being able to get an education. I mean, the costs are rising and rising. And although, theoretically, jobs are rising in some cases, in some places, costs of fuel, things like that may be going down. Electricity costs are going up. The RAM prices are going up for my upcoming Steam machine. It's crushing regular people. And so we absolutely see that the economy is in a very weird state. And now we're seeing, for example, that hard drive prices, SSD prices, GPUs, are locked down for like years at a time now, that like regular people aren't going to be able to just buy these things, and there's like no relief in sight. And so right now, the entire economy is being propped up. The stock market is being propped up by the speculation in artificial intelligence. Is it a bubble or not? Now, I am a child of the dot-com bubble. I was there right on the front lines when the dot-com bubble crashed. I was in a company that was building websites. We had a ton of interest leading up to March, the year 2000. And then it was like the bottom dropped out and we saw just carnage across the landscape. And the internet is a thing, right? Like we were all working on the internet, and here we are 25 years later and 26 years later, and the internet is as more popular than it ever was. Like, imagine how you would feel if I took the internet away from you. You would not like that. And so the reality was that the internet was going to be a gigantic, make an enormous difference. It's just that people didn't want to. It wasn't a good valuation to send kitty litter by mail to people. So things were overvalued and things crashed. And there was a ton of infrastructure that was built out with the dark fiber that eventually found its use. And in fact, we have this internet that we have today, thanks to the sort of overinvestment by the tech firms 25 years ago to build out all of this infrastructure, lay all this fiber that we now take advantage of. And so the amount of money that's being spent on AI today dwarfs the amount that was spent during the dot-com crash. That was adorable compared to the investment that's happening today. And that there are very few ways out. And the ways out are almost catastrophic. Like the one possibility is that this is a bubble and the stock market crashes and everybody's 401ks and RRSPs, as we call them in Canada, take an enormous hit. Your investment is stalled out. You're not able to retire for a decade, sort of like what happened with the lost decades in Japan. Like that's one possibility. The other possibility, and maybe more terrifying, is that it does work out, that they are correct and that AI goes on to consume all of human labor. And then how do we have jobs? Right? Like I've mentioned this on many times, that I am one clever AI away from being utterly unnecessary to you. Like I know you appreciate the fact that I'm an actual human being and I'm here relaying space news, but come on, you could be chatting with ChatGPT or Claude and be giving some interesting answers, and telling you that you're absolutely right and helping you confirm your wild theories about the cosmos. I joke, but I only exist right now because the AI is not as good as me yet. Later on, I will exist because you have a nostalgic memory of me providing space news and you sort of keep me around like a pet. But sending data centers to space, which sounds crazy, is not entirely crazy. that the amount of money that is being spent, the energy that is required, the resources that are required are in the hundreds of billions of dollars per year today. They will be trillions of dollars. If this thing works out, they will be in the trillions of dollars in the future that I have experienced both the pluses and the minuses of how quickly AI is gobbling up every part of our lives. I can imagine scenarios where it just keeps going. And that, in fact, sending a dedicated computer to space, that all it does is spends a year crunching a bunch of data, and then at the end of that year sends you home a gigabyte of information, that is actually an efficient use of space resources, that it gets those data centers to stop gobbling up rivers and streams and pumping out pollution with coal plants and natural gas, and puts it out into space off Earth. And then all it does is sends the work home, and that enough people who are serious take this seriously, that I have to be open to the possibility that this is the direction that it's going to go. And the child space nerd in me says, yeah, right? Like what did you think becoming a solar system spanning civilization was going to look like? You came up with a reason, you went to space, you then built out your space infrastructure, and then you set up on the moon, and then you went to Mars, and then you went off to other stars. Like, how would that happen, right? And then the part of me that's actually living through the transition goes, this is all really gross, and I don't like it, and I don't like the way this is going. And as a person with a computer science degree who is deeply enmeshed in all of the ongoing developments, I understand this very well. And we don't know how this is all going to play out yet. And all we can hope is that at some point, saner heads prevail, that the countries put regulations in place that make this not become another tragedy of the commons. And like the cynic in me and the cynic in you, I'm sure right now is just yelling at the TV or the phone or whatever, you're listening to your podcast, you're going, of course they won't. Of course, they will take their eyes off the ball, and the capitalists will build things that cause a negative impact on the rest of us, and the disparity between the rich and the poor grows ever wider. And now suddenly there are no more rungs that you can climb, that human labor is no longer necessary, and that really it's just the accumulation of capital. Like, this is a possible future that we face. And then what are the solutions to that? Is it, that there's some kind of living wage that's provided? Is it that the fruits of the AI companies has to be distributed amongst the populace? Who knows? But it is a very, very weird and a weird future that is running at us headlong, and we don't know how this is going to play out. And I think that you should not be overly cynical and say, this is just ridiculous, it's just another bubble, none of this is going to happen. Like, anybody who has worked in code, and I'm sure like anyone who's a programmer, anybody who has a computer science degree has experienced the change. And it really took hold in the last maybe 3 or 4 months that you went from AI's dumb, right? Like, it just makes a lot of bugs and I don't like it, to, oh God, like I am imagining things. I'm sending a swarm of agents out. They are delivering this thing and it works better than I could have possibly imagined. And I don't need to code anymore. Like, that is the change that has happened. And so that's on the one hand, you have to be open to the possibility that these things are going to happen. But at the same time, you can't be overly, sort of excited about it. You can't say, well, this is all great and there's no problem. Like, foot on the accelerator. Let's go full speed. What could go wrong? YOLO. No. All kinds of things can go wrong, and we are experiencing all of the things that can go wrong, from it affecting people's mental health states, to people getting bad advice, to excessive energy use, diminishing resources, putting pollutants into communities, to crushing people's job prospects, all the way up to existential issues. The potential extermination of humanity is on the table. And, if you want to see my thoughts on that, I've got a whole interview that I did on Doom Debates where I talked to Liron Shapira about, my perspective on that. And we mostly talk about space and stuff, but we also talk about sort of my P-Doom. And I think that it comes kind of back to which is that the flaws in our economy, back to your original question, Mr. Spaceman, the flaws in our economy, the flaws in the way we've done things are now magnified, accelerating, and hopefully someone can put the brakes on to at least give us a chance to digest what is one of the most dramatic changes in human history in a way that minimizes its impact on the planet and on us as people and the future of humanity. It's time to shout out our new patrons at the $5 level and above. Ron Kelbear, Chris Vincent, Jim DeRochers, Urban Knight, Azra Kumrudin, Antonitis, Mike Breslin, Jeff Geiser, Chris Sullivan, and Michael Richards. Join our community at patreon.com/universe today. Jay Peterson, SpaceX wants to launch 1 million satellites using a mass driver on the moon. How would those satellites circularize their orbits? Wouldn't the G-forces of a realistic mass driver break regular rockets? So that is a great question. And this is sort of like a nuance on this idea and sort of give people a little bit of background. Elon Musk has changed his mind and no longer wants to make Mars the first priority for human exploration, wants to start with the moon. And one of the key components of this sort of moon first strategy is that you're going to build this city on the moon, and that moon city is going to be building artificial intelligence data centers on the surface, and then it's going to be launching them into orbit using a mass driver. And this idea of a lunar-based mass driver is not crazy. Using mass drivers on Earth is just borderline crazy because the energy levels involved will tear the mass driver apart every time you try to launch it. And the atmosphere is so thick that anything you launch at those kinds of velocities will ignite, and turn into essentially re-entering the Earth's atmosphere from the bottom at the thickest part. But once you're on the moon, you have no atmosphere, the surface gravity is dramatically lower, and it is theoretically possible with the kind of technology that we have today to be able to launch stuff off of the moon purely through electricity. There's tons of solar power available on the moon. The surface of the moon is made of metal and rock and oxygen. So you've got silicon, you've got oxygen, you've got titanium, aluminum, iron, all of these minerals sitting there on the surface of the moon that you can just access to turn into the kinds of things that go into solar panels, the kinds of infrastructure that you would need for a satellite. And so then they would send the processors from Earth. Down the road, they may actually build chip fabs on the moon, but who knows? And then they would build the actual satellite on the moon, and then they would deploy it on this mass driver, and they would send it away. The trick is that, yes, if you wanted to make a satellite that was going to go into orbit around the moon, then you would need some way to circularize its orbit. Because essentially, if you can't circularize the orbit, then any single kick is going to bring this object back down to hit the moon. But if you send it greater than the escape velocity of the moon, then the object goes into Earth orbit. And so now your satellite is orbiting around the Earth in the same way that the moon is orbiting around the Earth. If you give it an even higher velocity, then you're putting it into solar orbit. And so now it is orbiting around the sun in the way that the Earth is orbiting around the sun. If you give it even more velocity, now you're putting it into escape velocity from the solar system. You're essentially putting it into Milky Way orbit. And you sort of keep going, right? With more and more velocity. And so you could put stuff into orbit around the Earth. And in fact, this is sort of the idea of the O'Neill cylinders back in the 1970s. They were sort of thinking about how you could build giant space stations at the L4, L5 points of the Earth-Moon Lagrange system. And you would be using mass drivers to launch material off the surface of the moon up to L4, L5, and then they would be collected together and turned into these giant stations. Now, you probably still want some kind of propulsion system on board your spacecraft to be able to reposition itself, move it, avoid objects, things like that. So you don't need like a full-on big rocket, but you're probably going to want an ion engine like the SpaceX satellites have. But then you're very far away from the Earth. And so communication time from whatever orbit you're on to go all the way down to the surface of the Earth is going to take you a while. And that maybe people are going to want these AI satellites closer to the Earth. I don't want them closer to Earth, but people might want that. And so then they are going to need more propulsion to get closer and closer to the Earth, because it's actually difficult to sort of decrease your orbit. It requires a lot of fuel to be able to get into orbit around the Earth again. And then the question you're asking is about the forces involved. Like, will a rocket be able to handle the launch force of this? And you would be amazed at how much force just a pure folded up satellite could handle. Much more force than a human could handle. And so if the force is too high and you think you're going to be smashing your satellites as you're accelerating them with the mass driver, then you make the runway longer. It's like maybe you find a mountain that is several kilometers high and you run your mass driver up the side of that mountain, getting faster and faster and faster. And at no point do the forces exceed what your satellites can handle in terms of that force. So this is an engineering challenge. And like, I want to just be super clear that all of this is like borderline science fiction, right? That building a city on the moon, really hard, building mass drivers on the moon, really hard, building the technological infrastructure to do all this, incredibly expensive and really difficult. And the only thing that makes it seem like, okay, maybe this might be possible down the road is just the enormous amount that the AI companies are spending to invest in their AI data centers here on Earth. They're spending hundreds of billions of dollars. It's expected by the end of the decade, they'll be spending trillions of dollars every year just on their AI infrastructure. And then like 100 billion here and 100 billion there to set up a city on the moon, if the economics make sense, actually isn't that crazy. So we're in a very unusual time in human history, and it may very well be that a use case for space exploration, for space industrialization has been invented, has been developed, and that this might be the thing that kicks off that solar system spanning civilization. Or it's a huge AI crash that's just around the corner and all these companies are going to lose money and we're all going to get super cheap GPUs any day now. And, we can all just live in gutted out data centers and put our skate parks into these gutted out data centers. So who knows what's going to happen? It's pretty fascinating to watch it. And terrifying. Darth X0. Will Elon's 1 million solar powered data center shade the Earth enough to help with global warming? I mean, no, thank you. So would a cloud of satellites orbiting around the Earth with enough density reduce the amount of illumination that is falling on the Earth? Yes. But I mean, if that is your goal, there are other ways to do that. Like you build something at the Earth-Sun L1 Lagrange point so that you are shading the Earth in this way that is really, really controllable. To just sort of have as a secondary thing that you are having more shadows falling on the Earth is very dangerous. And then it sort of kicks you into this place of essentially geoengineering, that you are trying to come up with a radical kind of you only live once solution to a problem that we have all of the tools at our disposal down here on the surface of the Earth to deal with. Reducing our emissions, switching over to renewable resources, sequestering carbon via planting forests by crunching up basalt and putting it in the ocean. Like, we have a lot of ways to be able to do this, and that there are unforeseen consequences for us relying on some kind of geoengineering solution, like launching various chemicals into the upper atmosphere, seeding enormous amounts of iron into the oceans to try and lock up more carbon. Like, there's a lot of ideas that theoretically could solve the problem, but that they're going to have all kinds of downstream consequences. The sad state is that we're probably getting close to this place where enough countries are being negatively impacted by the results of climate change that they're going to start taking actions into their own hands, that they're going to start doing these geoengineering mega projects on their own to try and solve the problem, because the world isn't coming to agreement, especially with the actions that we're seeing recently with the US sort of pulling away and doubling down on greenhouse gases. You're going to see other nations start to come together and make these kinds of agreements to try and do the geoengineering, which is a terrible idea, right? Like, this is not the way you want to do this. Whenever you think, oh, here's a simple solution, let's just block the sun's light from space. And then, oh, turns out, we weren't getting the right wavelengths and our crops are dying. Oh, it turns out, right, there are all these unforeseen consequences. And you would need a lot more, and they would need to be bigger, and they would need really be purpose-built to block sunlight. 1 million satellites is nothing compared to the amount of radiation that's coming into the Earth. All right, those are all the questions we had this episode. I know it's just like a couple of questions, but they were all kind of on theme, and so we thought we would collect them together, and a lot of people have been asking me about this, so there you go. Now, we have hit a very special milestone, and I am going to talk about it in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barry Griffin, Brian Bodie, Caradwin, Chuck Hawkins, Commander Balex, Cooper Anelli, Dark Finga, David Giltonen, David Matz, Evan.pro, Greg Feely, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Nordspace, OneStepForAnimals.org, Porobuk, Rinkaidu, Richard Williams, Sean Sargent, Stephen Falamunley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldebor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So as I was mentioning in the outro there, we've hit a very special milestone, and that is that this is the 400th question show that we have done on the channel. And I recently kind of put all of the questions into a database that I'm going to give you access to very soon. So that means there are about 4,500 questions that I have answered across 400 question shows since I began this process many years ago. And it's so much fun. And, you know, obviously we've tightened up the whole thing and got it to a point that, you know, I'm able to do the live stream as well as grab all the questions that people ask in the YouTube comments. And then we put that all together and then we edit it down and we have the regular show and then we have the overtime that's available to the patrons. And then we're able to reuse that. But still, it's amazing. And in fact, I also downloaded all of the comments and questions on my YouTube channel. And so there are 400,000 comments that have been posted on all of my videos on the YouTube channel. And about 100,000 of those are questions, like who, what, where, when, why, with a question mark or something, you know, some combo of that. And so when you think that I have answered about 5,000 of those questions in video form, I've been able to get to about 5% of the questions that people ask me, which is pretty cool. I feel like, you know, I feel sad for the 95% that I don't have time to get to, but still. So thank you, everybody who shows up for the live show and asks me questions. Everybody who puts your questions in the YouTube comments. I really enjoy that. A huge thank you to Chad, who has edited every single one of those 400 question shows. So thank you so much, Chad. And then of course, Anton, who edits Space Bites, but does a lot of the post-production and pre-production work on the question shows. So thanks for everyone who asked questions. Thanks to the team. Here's to another 400.